Thank you very much for the introduction. Good morning to everyone. I would like to speak here about how to communicate our data and information, particularly spatial information, in an effective way. I will focus on 3D as it is my part or my study of field. But first I will start with some introduction. I think that the motivation of this whole conference is about present spatial data in some form which is suitable for efficient and fast decision making. You do it using maps. I will try to show you that maybe sometimes other way is also possible to deal with the geodata, but I will come to that later. I will start with this hierarchy of data turning to information, information turning to knowledge, and knowledge to wisdom. We talk about this. We all know that data are symbols, and creating a map or some visualization, we do transform the data into information. When an experienced user, a user who understands what we did with the data, then can to discuss upon the visualization, and there some knowledge can appear, and even maybe a wisdom can appear at the very end. But on the technological side, we stay on the level of turning data to information, of course. Well, we believe that if we create some good visualization, it will help people to understand the data, and this process will start ideally. Okay, so talking about the data, we all know that based on spatial aspect, we deal with rasters and vectors, right? So rasters are mosaics, talking about regular rasters or triangular irregular network. In vectors, we talk about point line, polyline, polygon, and in 3D, also 3D models, of course. What we face in, let's say, in these years is that we were all used to have well-structured data. But what is now going on is that you have a lot of non-structured data all around the internet, and you need to somehow understand them if you want to visualize them, of course. What we are known about, we have data organized in tables and in some entity relation-based database, right? But there are also other structures of the data, let's say hierarchical structure or tree structure of the data, or even general graph. And if you look especially to the third one, it's let's say the game changer who tries to put at least some structure into the non-structured data all around the internet. I'm talking about the RDF format, which is used for description of linked data. So when we want to work with the data around, we need to be able to, let's say, read the data and display it. Therefore, we develop a technology which is based on OpenLayers technology and Cesium plugin. We created an HS layers NG. Well, let's say it's some framework which works with the Cesium and OpenLayers, and basically adds various data connectors and also some graphical user environment which differs from OpenLayers, etc. But what is important for this is that we can read a really wide set of different data sets. Well, originally I was thinking about talk just about this technology, but when I prepared this presentation, and especially when I saw the presentation in previous days, I decided to do the presentation a bit more general. So I will present our technology as well, but you will notice these 4 icons in the top left corner. and you will see examples which were done in other technologies as well, because I think that it could help us to understand. All of these examples are done by our 3D GIS research group, and at the end I will share a link where you can find them if you are interested. Well, basically we are coming now to the 3D visualization. Well, is it useful? I will try to answer that question with the rest of my presentation. I see here some necessary conditions. I think that we should be able to handle spatial data, large spatial data, in an efficient way, which is harder in 3D than in 2 dimensions. And if we are able to connect different data structures. This is these necessary conditions, and when we have them, well, does the 3D visualization provide a different insight than 2-dimensional? Because otherwise, why would we need 3D? So I will try to answer that question as well. First of all, what do we look? This is the application I promised in abstract, and I have some short video here. It shows this one is two large data sets. Sorry, I don't know why it's blinking, but the video was okay. Anyway, it works somehow. So you see open land use, a data set which is all among European Union. You have their attributes which are coloring the map, and last but not least, if you go from that area and zoom to completely other area in Europe, you will get the data as well. There is some pre-processing of getting the data. So this is the first layer. The second layer is added here as a WMS service, and it's open transport map road network of Europe with calculated traffic volumes coming from well, OpenStreetMap and some parallel processing, which was our job in the project. So again, you can get the data from the whole Europe in a reasonable time at your screen in a browser, so you don't need any other technology for visualizing and basic querying of the data. So this is the first example I want to show here. The second one, so we can say that we can handle big data. That was the answer for the first question. The second question is, can we handle various data structures? So here you can see that when I clicked into the map, I gathered the data in this time from DBpedia, which are linked data. So this is the demonstration that we are able to access linked data space on the internet. When I come to the very end of the video, you can see here that we are able to visualize these small points. These are smart points of interest, a worldwide database which is run, open database worldwide, which is run by my colleague Otakar Čerba, and it's in RDF format, accessible to visualize, so we access to this data. So this is how we can handle really various data structures. You already saw some polygons. You saw extruded polygons, and you will see some other examples of more data structures now. I'm sorry, I didn't have all the videos on my laptop, so I just prepared some visualization from YouTube. We have it, so I switch from the presentation here. Talking about different data types, you can see here all traditional data types from points, lines, polygons to 3D models. This is a study case of a castle or Chateau Kozel, which we developed with the cooperation of the National Heritage Institute. So you can see that the 3D visualization can be really complex if we want. If we go to, let's say, other project we had, our question now is, can we get some more insight in 3D than in two-dimensional space. Well, let's say this is on top-down projection of a city of Terezín, city where a concentration camp was during the Second World War. And if I play the video, you can see that when I turn to 3D, actually, I of course get another impression of how the city looked like during the war, and I'm here connected to some attribute basis to get some information about what was happening there. Talking about maybe more analytical phenomenon, there's another example about approaching zones to Oslo airport. We prepared for the Carter company who's working for Norwegian Army. You can see zones in which planes are allowed to approach to the airport, and you can see that this is in really different way visualized than in these JAC NATO maps, if you saw some. So I believe that here we can really get another insight than in two dimensionals. So I'm now coming back to my presentation, and the next slide shows output from another project. This is a visualization of a more analytical layer. The layer we see here is estimation of crop yield, which is calculated from some satellite data in combination with the data from farms. And if you put this information on top of topography, you can see these. I should mention that these blue zones are zones with lower crop yield estimation, and zones with which are going to green, yellow, and red are the better ones. So you can compare it to the topography, and you can see there are some consequences. If I go further, I have some example from a building. You can see the complex 3D structure here. It's not very clear view, but when you focus, you can see at the center of the screen there are some elevators, and the graph in blue here shows the typical movement there. It's an indoor GML navigational graph, and you can compare the general state and the evacuation zones. And these red evacuation zones, they show that during the evacuation you cannot use the lift, which is something which is hard to get such an information from a layer of 6 or 7 floor plans. Next example is about a view shed. When you go to a crossroad, you know that you should be able to see which cars are approaching which way. If you do such a map in 2 dimensions, you probably are not able to see the full scene. This is a measurement in 3D via laser scan. And you can now see that there is a high wall here in the top left corner, which wouldn't be clearly visible from 2-dimensional map. Or if you want to calculate such an analysis in 2 dimensions, you would probably struggle with the at least 2.5 constraint. So maybe a wall would be fine, but if you have there some more complex structures like trees, etc., then you really need the 3rd dimension for the analysis at least, and then you can use it for the visualization as well. Well, now I'm coming into again showing a result of analytical phenomenon. It's Now you see it in 2 dimensions. What you see, it's noise level produced by traffic. The red ones are the worst, and then it goes to other colors. And if you want to see how the noise is spreading among the various levels in the city, like for the first floor, second floor, etc., it's much better to visualize the data in 3D, so you can see how it changes. Again, for here, it was necessary first to calculate the noise distribution in 3D, and then we were able to visualize it. And you can compare. If you have 2-dimensional map, you would need a set of map to show how it looks like in different floors. Well, last but not least, there is a combination of 3D and time. So you can see the 3D scene, and the time is coming and showing how the noise is changing during the day period. There is not many time slices, just 3 of them, but for the demonstration of how it could work in a dynamic visualization of 3D and time, I think it's a good to see this. Okay, so now my question was, is 3D visualization needed? Well, the answer is up to all of you. I think that yes, when it makes a difference, and I think that I've provided some examples when it makes a difference, so hopefully you get some inspiration here. While talking generally, I would say it's necessary to keep the connection to attributes. Sometimes, or many times, you can see 3D visualizations which are showing just pretty visualization but no connection to the attributes. So that's a very big problem, that there is the so-called wow effect, and then on the second day you see that the visualizations is useless. So first of all, attributes are needed. Second is that the closer the scale is, we cannot talk about scale exactly in 3D, but about the granularity. Let's say the closer we are to the objects, there is a higher probability 3D is useful, because if you display a 3D map of a whole country, you get just plastic relief, whatever. It could be, I believe, used not just for nice maps of towns, but to be used for presentation of analytical phenomenon as well. And the very last sentence from me, as I am more a GIS guy, not a cartography guy, I think that you saw already in my visualizations that there is a lot of work for cartographers for better visualization. Well, actually, a colleague of mine, we just finished a PhD thesis about questions related to 3D cartography. So we try to focus on this issue in upcoming years. So maybe I will have some update later on. Well, that's all from me. Thank you for your time.
So you hinted in both your introduction and your conclusion about analytical data that's not necessarily, that is spatial but not related to maps. Do you have any example of what you're thinking there?
I don't know if I get your question right, because your question is about the analytical data which are not spatial aware. But my meaning of this analytical data was, showing, for example, the layer of visibility from particular point. So this is data coming from some GIS analysis, and then I visualize them in 3D. The same is when I visualize the data about the noise pollution. Again, it's calculated in some software, and then visualize. So there is a spatial context, but if not sure I answer your question, so if you can rephrase it.
Yeah, so I was thinking more in terms of, so my background is data science, and so data is highly dimensional. Usually we try to reduce it to a 2D or 3D dimension so that it makes some sense for humans, but it's alternate representation of the reality of this very high dimensionality. Can you use these types of approach with your software?
Well, then it depends highly on the data structures, and I think that we don't have a general solution for, you have multi-dimensional data and you can visualize them in 3D or 2D or 3D in time, whatever. But we have the application under our control. So once we get the idea how to transform the data and visualize it, then it's possible to implement it. So because you are talking about reducing the dimensions of the data, so this is not a big deal to implement it at the very end. What is important is to know because you need to cut something off when you lose the dimension. So you need to decide what is important and how, what will be on the XZ, what will be on X, Y, and X. And therefore, this is something which should be usually really discussed in detail, and then some process could be set up.